Laboratory exercise number 4, DIY ice cream making at home. So the first step we need to do is pour all the ingredients such as all-purpose cream as an alternative to the heavy cream. Next ingredient is the milk, 2 tablespoons of white sugar, and 1/4 teaspoon of vanilla extract, and mix it all together. After mixing using the thermometer, we will measure its temperature. And now we are going to prepare the flavor. So remove the filling of the Oreo, and then we are going to crush it using our clean hand. And now we are going to mix it with the mixture. After mixing, we are going to measure again its temperature. And now we are going to prepare an ice. So put it in the container and measure its temperature. So initially, we have 0 degrees Celsius or 32 degree Fahrenheit ice temperature. And after recording, we will put 1/2 or 3/4 salt or sodium chloride to a container and then shake it gently for 30 to 45 seconds. After shaking gently, we are going to measure again its temperature. And as I have observed, the temperature of the ice gets lower than the regular ice. And after recording, we will put it in another Ziploc. And we are going to put the cream inside the Ziploc full of ice and then shake it side to side. And continue shaking the bag for 10 to 15 minutes or until mixture solidified. So record the mixture temperature every minute until solid product form. After 10 minutes, we're going to open the gallon bag and measure the temperature using the thermometer. As of this moment, the cream is not yet frozen completely, but some parts are freeze and chilled. So after adding 10 minutes, here's the final result. And then we're going to measure its temperature. And as of this moment, it reached negative 5 degrees Celsius. And there you go. Here is our final product. The first thing that I have observed is the ice. Initially, the freezing point at which liquid water turns into solid or ice is at 0 degrees Celsius, which is probably why the initial temperature of the ice in my experiment is 0 degrees Celsius. When I add sodium chloride or salt, the temperature gets even cooler or lower, which turns into negative 10 degrees Celsius. Now the ice cream mixture. Its temperature is 16 degrees Celsius, but after 1 minute inside the Ziploc full of ice with salt, it lowers the temperature to 9 degrees Celsius, and as time increases, the mixture's temperature gets even colder. However, during this experiment, I noticed that ice melted quickly as I added salt, leaving very cold salt water. Here is the twist. We all know that a cube of regular ice, for example in an ice cream tray, the ice will melt as we leave it outside the freezer, but when we put it back, it will gradually revert to a solid base. But when we put salt into ice, the ice will still melt but it will not refreeze. After 10 minutes of shaking the mixture inside the Ziploc with ice and salt, the mixture did not freeze completely, although chilled and some parts froze. Therefore, I decided to repeat the step of shaking the gallon of ice bag with cream mixture inside for another 10 minutes. And after that, I was able to freeze my ice cream mixture completely. Now it looks contradicting how melted ice can freeze the ice cream mixture. The science behind this is the more salt we add, the more it impacts the ice freezing and melting points. As we add salt, the ice's ability to freeze is disrupted. This change in melting point forced the ice to start absorbing energy from its surroundings, which caused it to melt at a considerably lower temperature than usual. The ice will pull its energy to melt from the cream mixture and the surrounding. Therefore, the cream mixture will lose its energy. As ice absorbs energy from the warm cream, it progressively transforms from solid state to a liquid form. While the cream is losing energy, it changes from a liquid to a solid state. That's why we have an ice cream. It is important in my future career as medical technologist because colligative properties such as freezing point depression and boiling point elevation can determine the molecular weight of a soluble liquid as we deal with many chemicals, substances, and solutions.